Math 3, Unit 2, Logarithms. The logarithm of a number is the exponent by which another fixed value, the base, must be raised to produce that number. Exponent. So logs are inverses of exponentials. So we did inverses before where you have to switch your x and y. We did exponentials, and now these are logs, and they are the inverse of exponentials. We're going to first talk about converting between log and exponent form. We can easily solve this 2 to the x equals 8 by guessing and checking, but what if we had something like 3 to the x equals 8? So then to solve this, if y equals b to the x, then log base b of y equals x. I like to look at it like this way. B to the x equals y, and you're kind of making an L, log base b of y equals x. It's kind of an L. So your base on your exponent is always your base on your log, and the outside is what goes inside your log, and then your exponent is what your log equals. So exponent equals, maybe that helps. And then the other way is if you had log base b of y equals x like this. To convert it to exponential form, you kind of make an e, which is for exponent, and you're going to go like this. So b to the x equals y. Kind of how that works. So I hope that maybe those little tricks help you. Natural logs, if this is not an I or a 1, it is an L, LN, that's a common mistake. It's the log to the base b of a positive number to find y. Okay, so if we have y equals e to the x power, e is the number 2.7182881 yada yada. Okay, that is, it's like pi, it's a static number, and we use e because it's the exponential. That's what it's used for most of the time. It's a higher level of math than we really get into why it's e. So that's e. Log, natural log, base e, so it's the natural log. So if your base is e, the inverse is the natural log, not just regular log base e. That e there is understood. So if you have log base e, that's equal to the natural log. And natural log base e is just, that's understood. You don't need to write that there. So we're going to start with converting. Write the following in log or natural log form. So I like to switch it around. 5 squared equals 25. I'm going to convert that. So I've got log base 5 of 25 is going to equal 2. I'm just going to use that pattern. So log base 5 of 25 is 2. That's all we're doing. B, log base 3 of 729 equals your exponent of 6. C, it's already written the correct way. Log base 1/2 of 1/8 equals 3. So just real quick, when we have exponents and we have logs, your exponents are superscripts. That means they're smaller and up top. Your log bases, those bases are called subscripts, which means they're smaller and down below. So be careful how you write it. This one, log base 10 of 1 is 0. And then these last two, we would have log base e of 54.6 equals 4. Please do not leave it as log base e. Make sure you write the natural log of 54.6 equals 4. Here, same situation. Log base e of 1096.6 equals 7. Or the natural log of 1096.6 equals 7. So that would be your answer, and that would be your answer. evaluate. To evaluate these, we are going to set them equal to x and convert them to exponential form. So converting to exponential goes like this. We have 8 to the x equals 16. So we can't raise 16 to any power to make it, or we can't raise 8 to any power to make it 16. 8 times 2 is 16, but 8 squared is 64. So this is where it's kind of important to know your exponents or to be able to use your calculator quickly. 2 squared, right, is 4. 2 cubed is 8. 2 to the 4th is 16. So what we're going to do is we're going to change the base to make the bases the same. Then we can cancel out the bases and solve the exponents. So 8 is the same thing as 2 cubed. And 16 is the same thing as 2 to the 4th. Raise a power to a power, you're multiplying. Once you've got the same base on both sides, you can cancel those out and you get 3x equals 4. Divide both sides by 3. You get x equals 4/3. The next one, we'll set that equal to x and convert it to exponential form. So I have 64 to the x equals 1/32. We're using our exponential rules here. 64 is 8 squared, it's 4 cubed, but it's also 2 to the 5th is 32, 2 to the 6th is 64. Okay, so these are things that you need to be able to figure out if you don't know them right off the top of your head. Figure out what base you can use it as. So 2 to the 6th is the same thing as 64. Well, 32, 1/32, if it's in the denominator, I can move it to the numerator by giving it a negative exponent. So I have 32 to the negative first power. On the left here, raise a power to a power, you're multiplying. Right here, 32 is the same thing as 2 to the 5th. So I have 2 to the 5th to the negative first, which is 2 to the 6x equals 2 to the negative 5th. Cancel those out. You get 6x equals negative 5. Divide both sides by 6. X equals negative 5/6. All right, a couple more. Log base 9 of 27 equals x. So I'm going to convert that to exponential form. 9 to the x equals 27. So 9 I cannot get by doing anything to 2, but I can by 3. 3 squared is 9. 3 cubed is 27. So maybe that helps there. So I can change this to be 3 squared to the x, and 27, oops, is 3 cubed. Sorry, I almost wrote 2. Raise a power to a power, you're multiplying. 3 to the 2x equals 3 cubed. The bases are the same now, so you can cancel those out. 2x equals 3. Divide both sides by 2. X equals 3/2. D, set it equal to x, convert it to exponential form. 10 to the x equals 10. Well, we already have the same base. When there's not an exponent, it's an understood 1. Cancel those out. X equals 1. When you have the natural log, there is nothing you can do to solve that outside of using your calculator. So to use your calculator on that, you are going to hit the natural log button, which is to the left of the number 4. So we have the natural log of 42, and then typically it will tell you to round to the nearest thousandth, which is 3 decimal places. So that is equal to 3.738. That's 6 rounds, that's 7 up to an 8. Natural log of 8, 2.079. Now, change of base and common log. So first of all, the common log is log base 10. So anytime that the base is 10, you don't have to write it. Anytime that there's not a base written, it's an understood 10. That's really important. Please make sure you know that. Logarithmic function, inverse of an exponential, we already talked about that. And then the natural log is the inverse of the e function. We talked about that too. So if it's a natural log, then the base is an understood e. So if we had something like natural log of x equals y and it wanted us to convert that to exponential form, we would write in our base of e and then convert it that way, e to the y equals x. Okay. Rewrite, so the power property of log is when you have log base b of y to the a power. So if you have an exponent inside your log, the power property says that you can bring that out front. A times log base b to the y. Okay? You can bring that out front. So right here, anytime I have an exponent, I can bring it out front. I have 4 log of base 3 of x. This one, I can bring it up and move it to an exponent. It just depends on what you're doing, what you're going to need to use that for. And then this last one, take that exponent and bring it out front. That's the power property. Change of base formula. If you have log base b of m, old calculators, like the one that I have right here, does not let you change the base inside your calculator. So whenever you type in log, the log button on your calculator is just the common log, base 10. So the change of base formula is the common log of what you're taking the log of divided by the common log of your base. So when it says to use the change of base formula, you won't have to because you'll have it on your calculator, but you will see questions like, which of these is the proper way to use the change of base formula, or what is the change of base formula? And it's real simple. So all you have to do is write log of 15 divided by log of 3. And I can plug that into this calculator. Just make sure that you end those parentheses. You can plug this into the calculator on your phone or whatever. 2.465. Here, this one will be log of 400 divided by log of 5. 3.723. And then the last one, log of 12 divided by log of 6. 1.387. One other thing I do want to show you is the not having to change the base. You can check the ones that we did up top in your calculator, as long as your variable is on the outside. To find that in your calculator, you're just going to go to math, and then all the way down at the bottom is a log base, and it lets you change the base of the log. So here, log base 8 of 16, 1.333, negative fraction, oops, 4/3. You can do that one here as well, just to show you log base, 64 of 1/32. There are lots of times when you will not be able to do this and get an exact number. So just make sure that you are aware of how to do everything with changing the base of your exponential and on your calculator.